Hello everyone, if you want to learn line by line code implementation of this live video demo in which a deep learning architecture first detect the face and then based on facial features it specify the emotion of a person, either he's sad or a person is for example happy or a person is for example surprised. Okay, so if you want to learn all this, stay tuned till end of this video. Let's get started. So my name's Shanula and I'm a PhD student at Inha University, South Korea, and my major is computer vision and deep learning. In this video we will be covering face emotion recognition, and as a programming language we will use Python, and for loading an image and overlaying this rectangle and this text data we will use OpenCV. And for face emotion recognition we will not train the dataset, rather we can use a pre-trained deep learning library which is DeepFace. It contains a lot of pre-trained deep learning architectures for face emotion recognition. One extra feature of DeepFace is that not only it specifies the emotion of a face, rather it can detect the age of a person or a race of a person. We will see in the video. Okay, so let's get started. This is the outline of my video, and in which we will start with a pre-stored image. For example, this is an image, and in over here you can see that this guy is feared, right, and this girl is sad, and this boy is happy, and this man is surprised. So first we will start with image, a simple image, right? So it's better that divide and conquer, right? So we will start with a simple image and then we will proceed. After overcoming this problem and getting some skill over image processing, then we will deploy in the live video demo. So video is nothing but a set of images, right? So if we have a lot of frames, for example a typical video has 25 frames per second, right? So video is nothing but it's a combination of images. So then after applying face emotion recognition on pre-stored image, we will deploy live our architecture, deep learning architecture on live webcam demo. So before diving into coding, so it's better that we should have some brainstorming, right? So let's have some literature review. So in 2013, Ian Goodfellow along with his colleagues presented a paper in which he published 3 different data sets, and one of them was face emotion recognition. Okay, FER 2013. It's a well-known face emotion recognition dataset because it was a part of Kaggle competition as well. And one thing I want to tell you that Kaggle is again a very big platform in which they usually post a problem of industry, and then deep learning experts across the world, they try to resolve it and they come up with a very best solution. This is how deep learning is revolutionizing day by day. So let's review a data set, what's inside. So one of the problem in the data set was imbalance problem. So why we have imbalance problems? So actually let me tell you some background. Actually this data set was generated by cropping the already posted videos and images on the internet. So if we have a lot of public data set already available, so as I told you that video is nothing but a set of images, so they crop from different video sources, for example YouTube videos and others. They crop different faces, they detect the faces and crop them, and then based on deep learning or maybe some hybrid technology based on some annotators as well, they specify and divide into different categories. So one of the problem was imbalance problem, and imbalance means, for example, disgust has only 436 samples, or rather happy has 7214 samples, right? So if we just give this data set to a deep learning architecture, so it will be biased towards happy. So it's better that before going towards the training, we should resolve the imbalance, so that all of these 7 classes like angry, disgust, fear, happy, sad, surprise and neutral, they should have same set of samples, right? So they should be in similar length, but you can see that it's not, right? So this was an imbalance problem. So one of the solution for imbalance problem is data augmentation, and data augmentation means addition, right? So we can increase. How we can increase? One of the technique is GAN, generative adversarial neural network. So for example, we can rotate image as well, like GANs can regenerate fictitious images, okay, by training it. So this is one of the technique. Another technique is that we can scale, translate, rotate this image and generate more data. So in that case, in this regard, it can be equalized. Another problem was intra-class variation of FER. For example, all of them are from belong to same category, like angry. All of them, it's angry, right? But it contains face image and for example a sketch image and a painting as well, okay, and a cartoonistic image as well. So it contains very variety, right? That is why intra-class variation. So for deep learning, it should not be overfitted. And overfitting means that, for example, your deep learning architecture is performing very well on training dataset, but once we deploy it in a testing or unknown dataset, it do not perform. So definitely it has a class variation, so we should avoid overfitting, right? Okay, another problem is occlusion, and occlusion means, for example, something is covered. So in this phase, in this picture, for example, a person is covering his face with his hands, right? So this will be very hard to detect. For a deep learning architecture, it will be very hard to detect the emotion of this person, right? Another problem is occlusion. Yeah, we just covered the occlusion. And contrast variation. For example, contrast means that this image is too dark and this image is very white, okay? So in image processing, we have a gray levels, right? So it is towards 0 and it is towards 255. So white color is 255 and the black colors is 0. So it has a lot of contrast variation, right? So we have different contrast. Look at this image, it's very different. And similarly, we have eyeglasses, and for example, this guy or a girl is wearing glasses, and eyes are very important facial features, right? If specifying my eye, like if I mean for expressing surprise, definitely I would I can use my eyes to depict that I am surprised, right? So eyes are very important features. Similarly, it has outliers, like for example, this image, as it was automatic cropping, so it mistakenly cropped some other images as well, which do not belong to an angry, but anyhow they kept it in a data set to have some challenge the deep learning architecture, right? So this was a problems. In this video, actually we will not be training this video. If you are interested in training this video, in training this data set, you can see our other videos. There are upcoming videos in which we will show you how to train a deep learning architecture on this data set. But the main reason behind explaining all these problems is that what is the problem in emotion recognition, like what's the problem for a deep learning architecture, that how to specify the emotion of a person. So it's a challenging problem, right? And additionally, it's not the only one way to detect emotions, right? So we do have a lot of other domains like biosignals, like a brain signal, which is EEG, and for example respiratory, our pulses like PPG, and other we do have other biosignals, and based on which we can also specify that either a person is happy or depressed. Like brain signal like EEG can easily detect that either a person is happy or not. So if he's thinking too much, he's very sad, okay, we can easily detect that as well. But this is not like covering a biosignal is not a topic of this presentation. So in this video, we will be only covering the face emotion recognition, and we will not train, or rather we will use DeepFace, which has already pre-trained models which are trained on FER and other datasets. Let's dive into the implementation. So for implementation, the tools we require is Anaconda. Anaconda is basically a package of multiple libraries and IDEs, and the IDE for programming we will be using Jupyter Notebook. Another candidates can be Spider, VS Code, but we will be using Jupyter Notebook in this video. As I told you before, that the library, deep learning library, we will use DeepFace, and which contains pre-trained models. And for image processing, like loading an image, overlaying rectangles, we will use OpenCV. Okay, let's get started. Okay, so for example, if you want to download Anaconda, So it's better that just write on Google download Anaconda, and then if you click the first link, then you will come over here, and at the downside of this link you can find that for Windows operating system you can download, and for Mac OS and Linux you can download according to your specification or operating system. You can download the setup. And for Windows, as you know, that it's super simple. All you need is to just download and next. Once you installed by clicking next, you will come up to this window. Like if you write after installing, if you write Anaconda Navigator, you click Anaconda Navigator, it will be this window will appear. Over here you can observe that some of them have a green button which depict install, and some of them have blue which depict launch. So actually I have already clicked install on Jupyter Notebook. If you, for example, install Anaconda, you have to click install and Jupyter Notebook will be installed. Okay, now I assume that you have installed Anaconda and Jupyter Notebook. Once you have installed, so it's better that we should have always we must have the folders, right? So it's a better method to save everything in your project folder. So for that, for example, first I click on Anaconda prompt, and then I visit my, for example, I visit my this project folder. I copy the path and then I paste. For example, let me zoom for you guys, and I write CD and then press this and then F. And now as I have already installed the Jupyter Notebook, so I will write Jupyter Notebook. Okay, now we have a Jupyter Notebook, and then we can have a new we can open a new Python Jupyter Notebook. Okay, so for example, let me move out this to here so that I can use my notes. Okay, so let's get started. Wait a second. Okay, so the first thing we are going to do is for example, OpenCV. Okay, so as I told you, so if you want to install OpenCV, just again you can go to the Anaconda prompt, but this time you have to run as administrator. Okay, because if you don't do it, then it might you might get some problem. So you just do it, run as administrator. Once you reach here, you can just for example, let me do it for you guys, right, and run as administrator. Sorry for that. Okay, then you can just write pip install like OpenCV Python. Okay, once you write and just enter, I'm not going to do it because I've already installed it. So I believe that till this point you have installed. And one other thing I want to tell you, that press shift plus enter for executing this one line, right? So I will press shift and enter. Once I shift and enter, as I already installed using pip install for basic one, and for full package you can execute this command. So once I have done import CV2, okay, now that I have open CV2, okay, let's go to Google. Okay, and for example, if I download happy boy image, if I write happy boy and I like, for example, this image, and I have already downloaded in my folder this image, right, of a happy boy. So let's copy the name of this happy boy. So okay, so img is equal to imcv2 dot imread, and this is image, and the extension of this is jpg. You can also check what's the extension. Okay, so this is jpg, and let me execute this. Once I have executed it, another very important library is for plotting is import matplotlib. So matplotlib is very important for plotting something. So again you can install pip install matplotlib. So once I have done like import matplotlib as .py plot as plt, let me display this image. So by default, actually this is by default is BGR. blue, green, and red. Okay, so by default OpenCV is based on BGR. So in this regard we can have another command. So rather than executing directly, we can have like this, like cv2.color BGR to RGB. So it's better. So now we have the similar image and we have loaded in this variable, right? So now we have an image. So in order to detect for example either a person is happy or not, as I told you before, we can use a DeepFace library. So I think we should have all libraries over here. Let me, okay, so again if you want to install DeepFace, just write the command pip install DeepFace and you will have it. Shift enter, I press shift enter and now it will take some time. And now I do have I have imported from DeepFace, import this DeepFace with a capital one, right? So once I do have it, so what I can do is okay, so this was my variable in which my image is stored. So now I can just check, for example, shift enter again. So it is actually deepface.analyze, it's just downloading something, so that is why it takes time downloading the pre-trained models. So predictions, shift enter. Now you can see it has detected the dominant emotion is happy, right? And the dominant race is Latino Hispanic, right? So the age is 25, which is wrong, I guess, and gender is again man, is right, and race can be Asian, right? So but the dominant, we have to check the dominant race, right, which is Latino Hispanic. So I think this might be correct, gender is correct, age is maybe wrong because he's not looks like 25, but the deep emotion, we are most concerned with a deep emotion, which is happy, which is the correct one. Okay, so if I write, for example, if I check the type of this variable, let me copy. So this is dictionary, right? So if this is dictionary, so another method is to check that the one of the dominant emotion, right? So if I check, this is happy, right? So I can just get only this, where this is a dictionary, so it's which actually index the index and value, right? So this is my index and this is my value, so I can access. Okay, so using Python programming, like if you want to access the dictionary, this is the way. Okay, now that we have detected that the guy is happy, so for example now what if we want to draw a rectangle on this guy? So DeepFace detected and processed this image as a raw, right? So we did not give him only the face, rather we give him we provide this whole image to DeepFace and it analyze itself. It also might have cropped the face and then process it. But in order to show it that where was the face, so for example in order to draw a rectangle across the face, so we can have another command which is called as face cascade. Okay, so this is face cascade and this is har cascade frontal face. So for this, you know that CV2, we already import CV2, and this is a function of, like, if you press CV2 dot, it will comes up automatically. Like if I press CV2 dot, if I try to write like this, so I have this one, right? Cascade classified, but this is missing, right? So in order to have this, let's Google it again, like har cascade for example frontal face, right? So if I press in Google and then I have already opened this, so this is the example. If I go to the folder, I can just download this har cascade frontal face and just right click and save link. And as I've already downloaded it, so in this video I'm not going to download, right? So you can just go into Google and just download this. Once you have already in your folder in which you are working, in your project folder, you have to write one another thing, this cv2.data.har cascade as well. In previous versions of the OpenCV you don't need to, but in this for example I believe that once you see this video you have to install OpenCV using this command pip install OpenCV, so it definitely install the latest OpenCV, right? So once you have installed the latest OpenCV, you have to write this command, and this is provided already. So once we execute this, shift enter. So let me clear this. So we have face cascade. Now in order to draw, now what we are doing, we are trying, for example, let's have some, we are trying to draw a rectangle across the face. Okay, so we are drawing. So for example, let me change this to markdown. Okay, so we are actually trying to draw a rectangle across the face. So face cascade cv2 dot, this is already executed, and for example, let me copy and paste my code. Okay, so before using this cascade image, it's a har cascade image. So what is har? Har is actually an algorithm name, and which was proposed by Viola and Jones, and it is also a part of MATLAB as well, because MATLAB also uses Viola Jones. So it's a very famous face recognition algorithm, not emotion recognition, right? It's used for face detection, right? So if you have multiple faces, you might have seen a lot of them. So in order to detect the face, har cascade or har features are the most promising features so far. So in order to use as it is based on gray, gray means that you don't need to have color image, you can just convert into gray. So gray is actually not 3-channel, or rather it has only 1 channel. So after converting to gray image, then you can have detect multiple scales, and then you can have multiple scales and draw a rectangle in all the faces. For example, if it has multiple faces, 3, 4 or 5 in one image, it will detect, and then we have to draw rectangle. Okay, and this is actually BGR. Again, as I told you, OpenCV deals with BGR. So this is blue, green and red. So actually only green is 255, so definitely the rectangle color would be blue, and this is the width of the line. So let me execute this command. Although I have executed this command on image, but actually I have not shown it. So let me execute this command again. You see, I have successfully drawn a rectangle over here. So now if we want to overlay a text on it, so the good thing is, for example, wait a second please. Okay, this is the image. Okay, so this is my font type, and then put text is my command, and then this is my text, right? So I'm actually already prediction. As I told you, what is prediction? This is happy, right? You can just write whatever you want to write. Okay, you can write anything else as well, but I'm doing it, we are going towards the live demo, right? So that is why we are preparing our ingredients for that. So this is for example 50-50 is the offset, which is too much. I think it should be 0 and 50, and this is row and column, and similarly I think 1 is enough, and RGB, so let's make it BGR. It is BGR. For example, it should be red. Okay, red in color is good. Let's execute this command, and then we have to show this again. Okay, you see it's happy. So now we can easily detect that this guy is happy. So we are going slowly and gradually towards our live demo. Similarly, we can write like a sad woman face. Okay, if I write sad woman face, you can see over here, you Google it, and I have just downloaded this image already. This is the image. So let me copy the name of this image, and then let me copy here, and I can copy all these commands. For example, I have to read it from the start. Okay, so let me copy this command and just replace it. Okay, let me check either the extension of this is same. Yeah, it's JPG. Okay, so it's same. So let me execute this, and in this regard, for example, let me do only predictions, right? So this is the prediction, or as my variable name is same. Okay, let me first plt.imshow mg. Okay, again it's simple, I should have this one, it's a BGR, right? We need RGB. Okay, so this is a girl image, and let's as our in our this variable we have this image, so let's execute it. Again it will download some pre-trained model, and it will, and okay, predictions, shift enter. Now you see the dominant race is Asian, right? So she's Asian, and the dominant emotion is sad. Okay, once I write over here as it was, it's automatic, right? So we can just go for it. So in deep emotions is sad, so she's sad, and gender is woman. You see the gender is woman. Very well, DeepFace is a really good library for that. So it has multiple deep learning pre-trained models. Okay, so once we have it, we can just repeat all these steps for having rectangle like that. So let's have some one another image. I have already downloaded feared man. We have already downloaded from the internet. Let me replace this. So this is the guy. For example, let's check this, and the most for example, I have not executed this. Let me execute it again, and then predictions. Okay, again the dominant race is Latino Hispanic, and gender is again man, and dominant emotion is fear, so he's fear, right? So again it has detected very brilliantly everything. So now we can go towards the live demo, right? Once we have everything, all the tools, we can go for the live demo. Okay, let's have some live demo. Okay, so now this is the part where we are going to start our real-time video demo for face emotion recognition. So as we explained already, that first the command is import CV2, and then from DeepFace we already covered these commands we have already covered. Similarly, we have already covered these commands, and this is the command to initiate your video camera. So you can just, it can be 0 or 1. You have to check whether it's either it's 0 or 1, right? So it's a dynamic code we have written. For example, if it is 0 or 1, I hope it will work, but you can just check your camera, that where your webcam is either registered as a device 0 or 1, or you can have multiple webcams. If you have, then definitely you have to specify the index of your webcam which you are using. So for my case, I had only one webcam, so that is why I'm just using my default one. Okay, so this is just a video opening, and once the video is open in capture variable, we have to check it while true, like it's infinite loop, right? So we are retrieving the frame and some other parameters by cap read. So this will change, this will read one image from a video, right? From video which is continuously running. Okay, once we have one frame, now like previously we specify its image, right? Image I am show. So in this case we will have a frame. And then it's super simple that we can have result DeepFace.analyze frame. Okay, and we have specified the action as well. So previously we have checked, so now we can just specify only actions is equal to emotion, rather than previously we had all of them. So it's a dictionary, as I explained earlier, so we can just have these actions, right? So once we have a result, it's already stored in this, like either a person is happy or sad or any other label we already categorized. Then we are converting into gray image. Why? Just to draw a rectangle. So this is the command these are the lines which we need to write to in order to draw a rectangle across the face, right? Once we have drawn the rectangle and we have specified either a person is happy, sad, or emotion is depicted, now we can just write whatever are the results. We can just write down the answers, and now we have a offset is 50-50, and we have like a in this case, for example, this is an image. For example, this is image, this is 0 0, and this can be our 50 50. So 50 50 pixels are offset, right? So then it's it's BGR. So this the color of the writing will be red, okay, and I think the rectangle will be green, BGR, right? So rectangle will be green and the writing will be red. And similarly we have this font size is bigger one. And now we are showing the, it can be original video, it can be demo video. It's just a name of your the video, right? Demo video. And then it's a wait key, and it just you have to write the commands. Let's write shift enter to execute it. Okay, once I have executed, so this is my window. So if I'm happy, it successfully detected I'm happy, and sorry for my expressions. And if I'm sad, so it's specify, and it's confused between angry and sad, right? What if I'm surprised? So it was surprised, but I'm really sorry that I could not express my emotions very correctly. That is why I made a video in the start. So it's really simple and it's very good one, and you can install it in your home. You can deploy this code in Raspberry Pi and any embedded system having a camera. So it's really easy. So for example, why it's slow, I think we have 2 videos of that is why it was slow, otherwise it's not. So let me close it again and let's run it again. Yeah, so I think it will not be slow. Actually it's not slow. And you can just be happy, it will automatically detect, right? So this was a part of a demo, and definitely next time we are coming for with another face emotion recognition video, in which we will start learning everything. And it's a little we have for example, let me close it. So next time we will, it's not closed, okay, let me stop it. So next time we will be coming with the demonstration video of face emotion recognition, in which we will actually train our deep learning architecture. Stay tuned, and please keep watching our channel and subscribe our channel for appreciation. Thank you so much.